Hi, and welcome to College Algebra 2.1. Today we're going to talk about linear equations within two variables, which sounds really fancy, but really it's just what you're normally with, because with linear equations in two variables, we almost always express them in terms of x and y anyway. So we're just talking about those same things. Some common equations that you should know, obviously slope, m equals delta y over delta x, also known as change in y over change in x. In coordinate form, we just do that as y2 minus y1 over x2 minus x1. Slope in general is also called the average rate of change. Slope-intercept form being y equals mx plus b, where m is the slope and b is the intercept. If you have the slope and the intercept, you write it in slope-intercept form. We also have point slope form, y equals m, parentheses, x minus x1 plus y1. This textbook puts the plus y1 right there. You're probably more familiar with it as y minus y1 equals m, x minus x1. If I was trying to get y by itself, we all agree we would just add y1 to both sides. So that's all it did. It just isolated it for the y term. And general form is when you get it equal to 0 typically, or equals c, often used in, systems of equations. We write multiple equations. Vertical line, x equals a, or a horizontal line, y equals b. Slope for a vertical line would be undefined. Slope for a horizontal line would be 0, because let's say I have something like this. Let's say for the sake of argument, x equals 3. This is a vertical line of x equals 3 because no matter what, along this red line, I never move left and right. So my x coordinate never changes. So if I were to calculate its slope, m equals change in y over change in x, and I were to pick two random coordinates such as here and here, well, the y changes. Let's say for the sake of argument, that's changing 6 from here to here. My x value never changes, so I get over 0. Well, dividing by 0 causes the issue. That's what we call that an undefined slope. Versus a y value that was consistent, let's say for the sake of argument, y equals 2. And I were to pick a couple coordinates here, like here and here. Again, delta y over delta x. Delta y, I don't go up and down at all, so that'd be 0. Delta x, that is some number. Again, let's say for the sake of argument, it is like 5. I can technically do 0 divided by 5. That would be 0. So that's perfectly fine. So that's why they are what they are in this case. Find the equation that goes through the point 1, 1, and 3, 4. So I'm going to label 1, 1 as x1, y1, 3, 4 as x2, y2. And the first thing I would do is find slope. So y2 minus y1 over x2 minus x1. So we would get 4 minus 1 over 3 minus 1 gives me 3 halves. And I would look, I don't have the y-intercept yet. Recall that the y-intercept as a coordinate would always be 0, comma b. And I don't have that yet, so I can pick one of these coordinates and I'm going to plug it right into point slope form using my slope and one of my coordinates. So m becomes 3 halves, x1 is 1, y1 is 1. And then I should go about simplifying this as best as I can. So the first thing I could do to simplify it would be to use the distribution property. So we would get down to this step right here of y equals 3 halves x minus 3 halves. And then we can combine like terms to get negative 1 half. And this would be slope-intercept form right there. If I were trying to get general form, again, I want it to equal 0, so I would simply subtract y from both sides. So this would be the general form. Here, oh, I don't need all this. Yeah, I'll just leave it. Let talk through. So parallel lines never intersect. They have the same slopes. So they would look something like this. So same slopes. Big important thing here. And perpendicular lines intersect at the right angle, they have opposite reciprocal slopes. So an example of that would be like 1/2 and -2/1, or just -2, or something like 2/3 and -3/2. The opposite part, meaning that one has to be positive, one has to be negative, and the reciprocal part means a flipped variant of the fraction. So, find the equation of the line through this coordinate that is parallel and perpendicular using this equation. The first thing I would do is I would find my slope. So that's exactly what I did right here. I subtracted 3x from both sides, and I divided everything by -2. So then I get the equation y equals 3/2 x minus 1/2, giving me an original slope of 3/2. Well, if I want to make something parallel, I know that I have to have the same slope, so that's going to have a slope of 3/2, and for perpendicular, that has to be an opposite reciprocal. So that's going to be -2/3. But from there, I'm just going to use this coordinate and plug it in. So we get y equals 3/2, x minus 1 plus -2, or -2 is perfectly fine. Of course, we could then, let's erase. We can, it still has there, that's not good. We can distribute this to both terms, and then of course we can combine like terms to get y equals 3/2 x minus 7/2. Here, same steps, distribute, and then I can combine like terms, and I would get y equals -2/3 x minus 4/3. Now, real-world application problems are story problems for the most part, from what every math class you've ever had has typically told you explicitly. You should find x, or find the y-intercept, or where is it when x equals blah. Unfortunately, if you were to go out into, for lack of a better word, the real world, problems and the functions aren't typically given. So typically we have to create our own. So that's kind of going to be our goal here. So my colleague, Mr. Creer, has made a lemonade stand over the summer to help supplement his income. He makes extra money on the side running a lemonade stand at campgrounds during the summer months. The table below shows his revenue from 2018 to 2023. He wants to plan renovations to his house, but doesn't know how much he can plan to make from the lemonade stand in the upcoming years. Can he predict his lemonade stand revenue for the years 2024 and 2025? Explain. So we have some data here. Years since 2018, 0, 1, 2, 3, 4, 5. Let's say for just organization, this is year 2018, because 0 years after 2018. This is 2019. This is 2020. This is 2021, 2022, and 2023. So what we're looking for is in year 2024 and year 2025. Now the nice thing is I know this is going to be year 6 and this is going to be year 7. But what we don't have are these revenue values. So I have two different variable concepts. So I'm going to call the years since 2018 my X values and the revenue in millions as our Y values. And the nice thing is I can plot all these as coordinates. So for example, 0 and 8.9, I could plot on the graph, and I've gone through and done that. Now looking at it, and we've talked about lines today, it's obvious that all my coordinates are not in a line. It's more of a parabolic shape in general, and then this guy over here. But we're going to focus on lines. So a couple things I can do. The first one is I'm going to construct a line based purely off our first two coordinates, because this coordinate's really important. It's actually my y-intercept. So if I go out and construct a line with these two coordinates, we have 0, 8.9, and I should probably make that in green just so it's consistent. I have 0, 8.9, and this coordinate 1, 9.2. So if I'm going to make a line with these two coordinates, the first thing I would do is find slope. So I have that kind of going on this next slide. I'm going to flip back and forth with these two slides. I apologize in advance. So I'm going to use those two coordinates to calculate my slope. And the nice thing is, again, 0 and 8.9, that serves as my y-intercept. So I can jump right to this equation of y equals 0.3x plus 8.9. And if I'm trying to find the revenue in 2024, we already talked about that x being 6. So I can plug that 6 into the equation we just created to project about $10.7 million. The problem is if I flip back to this, is looking at this line that we've constructed, this green line doesn't feel super representative of our data because most of our actual values are certainly well above the prediction. So one thing we can also do on our calculators is do what's called linear regression. So if we take out our calculators, there's a couple ways we can go about doing this. We can press the stat key, and we're going to go to 1 for edit. This gives us a screen similar to this. Well, we're going to want to delete all this stuff, but not L1 or L2. And in L1, we're going to put all the x values we had earlier. And in L2, we're going to put all the y values. So we get, I'm just going to snap it. 0, 1, 2, 3, 4, and 5. And over here we get 8.9, 9.2, 9.7, 10.3, 11.9, and 11.7. Now, I can use these coordinates here to create a scatter plot of the data right here. So I'm going to go to second, y equals to get the stat plot, and I'm going to turn plot 1 on. I'm also going to want to clear out any functions in y equals. Looks like I'm good. And now I'm going to go to zoom, and I'm going to pick 9 for zoom stat. And this creates a scatter plot for me. As we can see, it's very similar to the one I've already constructed in these notes. The thing it doesn't have, though, it doesn't have a line modeling the data. So that step is go to stat, over to calc, and here we would pick what kind of equation we would try to model the data as. Like I said, seems more parabolic in nature, but for the sake of the focus, we're going to pick 4 for lin reg. So lin reg, x list L1, which is awesome. That's where we put our x values. Y list L2, awesome, where we put those. And I'm going to go to store rec EQ. I'm going to put my equation right in there. So I'm going to go to alpha. Not alpha trace, actually. Enter. And hit calculate. And it's going to type out an equation for me. So my equation we're going to get is right here. Y equals 0.65x plus 8.66. And again, I'm going to plug in 6 into my equation and project that I'm going to get about $12.56 million. The nice thing is because I did some extra steps here, you can graph and see this line with the data. So if we were to model that here, we would get something like this. Let's go with blue. Which, as you can see just by looking at the blue line here, that looks closer to the data that we have. That looks more representative. Obviously, it's not perfect, but it's certainly closer. Now, you don't have to make a scatter plot in here. We just did that for the visual. If you go straight from your equation, right, or sorry, your coordinates, right to Stat Calc 4 and just go down and hit calculate, that's certainly good enough. It still does everything just fine. Thank you for listening, and I hope you have a wonderful day.